Hello again. I'm trying the webcam feature, which I didn't know that just appeared today. So hello, you can see me now. You can also see Ruby. Let's see, can you see Ruby? Say hi, Ruby. Ruby's playing with me. Say hi. She's looking at me like I'm crazy. Say hi, Ruby. Ruby, say hi. Kaiser's over there in the hallway. He doesn't want to say hi. Alright. So, we were talking about how vaccines are inactive forms of the pathogen that are harmless, and they allow antibodies or B cells to bind to them and make memory cells, so that if the real infection comes, you can respond to the pathogen more quickly. Now, if we take a look at this graph, which is why I wanted to start a new video, is that you'll see after the first exposure to the antigen, the number of antibodies it makes are smaller in number. And this response, after the first exposure at day 0, takes a long time to get to this, about 17 days. And there's some lag time where there's actually very little antibodies to that can attach to the antigen. However, the second exposure, which is called the secondary immune response, if you take a look, it takes much less time. You're exposed here at day 28, and already by day, it almost looks like maybe 34, 35, 36, I can't really read the graph that well. You'll notice that not only is the amount of antigen higher, but the response is also much more quicker. So if this is a vaccine example, this would be the number of antibodies you would have after exposed to the vaccine for the first time. Now, the response takes a long time, but it doesn't matter because the vaccine is harmless. When you get exposed to the real pathogen, okay, which really is the first time you're getting exposed to the real pathogen, okay, but it's the second time you're being exposed to the antigen, you'll notice that you make more antibodies, so the antibodies are more likely to find the real pathogen, and you also make them much more quickly. So you're likely to get rid of the pathogen before it actually makes you sick. Now, in class today, we also talked about how one way to protect newborns while they're developing their immune system is to breastfeed. When you give someone antibodies, not B cells, but when you give someone antibodies either through injection or babies through breast milk, that is called passive immunity. You are temporarily protecting them, the baby, or if you're injecting them, temporarily giving them immunity to that virus or pathogen. It's temporary, though, because your body is not naturally making the antibody with B cells. You're only going to be immune to that pathogen for as long as the antibodies stay in your blood. And antibodies don't survive forever, or aren't in your blood forever. So this is passive immunity, because your body is not doing anything. You're just getting the antibodies from someone else. An example, again, is babies get antibodies through their mother's milk when they breastfeed. And it's also short-term. Over time, those antibodies will leave the blood, and then you will no longer have the immunity to it. Okay, so for homework, you have to answer guided questions, which are about this packet, and there's also a couple of, I think, like 4 or 5 longer questions on reviewing the endocrine system and the nervous system. Also, remember that you have to do your practice AP quiz on the Chapter 1 Biochemistry. That's due on Monday, and remember, it's being graded as a quiz. Alright, enjoy the weekend. See you all on Monday.